Thank you, Shauna. So you were talking about pithy and short, and then you invited me to present. So I'd like to thank you. I'd like to thank Tom Malcolm and Christopher Gully at the Carbon Talks program at the Centre for Dialogue for inviting me here to present to you today. My name is Nicholas Heap. I'm the BC Regional Director of the Canadian Wind Energy Association, or CanWIA. I'm based here in Vancouver, about 3 blocks east of here, and it's a pleasure to be here today. I think you're all here because you think that wind energy can reduce greenhouse gas emissions, and I'm here to say absolutely you're right. But I want to give you a larger case for wind energy in British Columbia. So I'm going to take you through a tour of all the other awesome things about wind energy, and we'll get to greenhouse gases at the end. Stay tuned because I think I have some interesting information to share with you about the other great aspects of wind energy as well. So a little bit about my organization, CanWIA. We represent 420 member organizations. That includes wind turbine manufacturers, component suppliers, wind energy project developers, owners and operators, and a whole range of service providers. That's folks like the professional biologists working on the environmental assessments, financial analysts, lawyers. They're all members of our organization. Now, CanWIA promotes the wind energy industry, but crucially, we promote the responsible and sustainable growth of wind energy in Canada, and that's why I'm pleased to work for them. Now, it used to be that folks like me, policy folks in the wind energy industry, were primarily concerned about making the costs work, about arguing for incentives, arguing for subsidies in order to bridge that price gap between a maturing clean energy technology and what was economically competitive. That's not our problem anymore. We've essentially bridged that price gap now. Our issue now is to make sure that a technology that has the potential to be extraordinarily low impact is extraordinarily low impact and that it works for communities. I'm going to be telling you a great deal about the benefits that wind energy has on the provincial scale, to ratepayers in general, to the globe as a whole when we look at the climate change situation. But we also have to make sure that wind energy works for local communities. And to that end, one of the things that I am very proud of my association for is that we've put out this best practices guide. This is a guide for local communities to hold up the bar, to keep the bar high, so that when wind energy developers come to your community, you can say, this is from your industry association. We expect full consultation. We expect meaningful input into how this development is done so that it benefits the local community, so that it benefits us, so that we have the best project we can have. So we take this very seriously, and it's a big part of the work I do. And now I'll move on. So globally, oh, what's that doing there?
Shows that you're in the right place now.
Yes, good. Excellent. I'm delighted. I'm delighted we're all here. Start of 2012, we have 238 megawatts of wind energy installed worldwide. As you can see, the country with the largest amount of wind energy installed is the People's Republic of China, followed by the United States in a very strong position, Germany, Spain, India. You'll see that Canada is on the list. We get our own little wedge of the pie. We're either a major minor country or we're a minor major country. But we do have a significant position in the global wind energy industry. What's more important is that wind energy is becoming a major source of generation within individual grids. The country of Denmark now gets over a quarter of its total electricity supply from wind energy. The state of South Dakota, over a fifth. Prince Edward Island gets a fifth of its electricity from wind energy, and so on down the list. The world as a whole gets 2% of its total electricity consumption is generated from wind energy. And in case 2% doesn't seem all that impressive, consider that Canada consumes just over 2% of the world's electricity. Next year, the output of the world's wind turbines would meet all of Canada's electricity needs. And here's Canada. So as of June, we had 5,500 megawatts of wind energy installed. By the end of the year, we will have considerable, more than that. When we look at the country as a whole, what we see is about 1/3 is located in the province of Ontario. We have another third shared between Alberta and Quebec, and the rest of the country takes the other third. And we are so very, very in the last third. In British Columbia, we now have 2 utility-scale wind farms in operation, and we have the single wind turbine up in North Vancouver. Right now, they supply about 1% of BC's energy needs, but by the end of this year, the Quality Wind project near Tumbler Ridge is expected to be in operation. We'll be supplying about 1.5% of the province's energy needs, and by the end of 2013, we have Cape Scott coming along. I'd have to say that at the end of the year, with almost 390 megawatts of wind energy, we will still be in the basement of wind energy production on a per capita basis in Canada. But after that, it will be a neck-and-neck race with Newfoundland and Labrador for 9th place. So, last year, a lot of my effort was spent on developing the case for wind. Oh, there it is. And we put together the Wind Vision 2025. And I don't have any copies here, but there's lots in the hallway. It looks just like that. We put together the case for wind in BC, and I am pleased to announce, and in fact I'm going to be telling you all about it, there is an extremely strong case for building wind energy in British Columbia. Our target in the Wind Vision for 2025 is for wind energy to supply 17% of BC's total electricity demand. Keep in mind that we're starting from just under 250 megawatts as we stand here now. So, we've got a long way to go, but I prefer to think of that as tremendous potential. So the first question you're going to ask when someone says, I think we should build over 5,000 megawatts of wind in about 13 years, you'd say, well, does anybody actually need that electricity? Is there any demand for the electrical power? And it's interesting, because if you look at BC Hydro's draft IRP, your answer would be, well, no. That's a really flat load growth chart. The light blue is the Future Clean IPP acquisitions. Presumably that's my sector. The purple bit is Site C. There's not a lot of energy growth going on there. But you have to ask yourself, the provincial government is talking about its BC Jobs Plan. It's talking about liquefied natural gas terminals. It's talking about shale gas development in the Northeast. There's a lot of talk about new mines opening up in the North. All of these are tremendously energy intensive industries. So the question is, if they're not showing up there, how are they powered? Well, the assumption in this is that they're powered by natural gas or they're powered by diesel. But that's a choice we can make. We can also choose to do something that looks more like this. This is BC Hydro's contingency plan. It's right at the end of their plan saying, what about other possibilities? Well, this is another possibility, which adds some of that stuff in. But to give it to you graphically, I'll show you the numbers here. The mid-load in the red is what BC Hydro is planning for. Okay? You'll notice that we're actually planning to run a deficit. We're planning to import electricity for 5 years, starting in 2016 out to 2021, and at that point, Site C comes in and fills this import hole. But it doesn't include the possibility of a third LNG plant, and there are now 5 LNG plants that are seriously underway in this province. It doesn't include the possibility that the Northwest Transmission Line that's being built up north of Hazelton might be fully occupied by new mines coming on, and it simply doesn't take into account any possibility of electrification of the load in Fort Nelson and the Horn River Basin. If we are to electrify aggressively, then we have a supply gap by 2021, within 10 years, that's equivalent to 1/3 of our total demand for electricity. Now, this is a demand that we could fill. This is power that we could supply instead of natural gas and instead of diesel. And by choosing not to supply it, it's not as though we're making all of that industrial development go away. That industrial development is going on a different track to us. And that's going to happen whether we make the decision for electrification or not. So that's the choice we have. So in answer to the question, do we actually need this electricity? I would say, yes, we do. Yes, we do if we are interested in keeping our greenhouse gas emissions down, if we're interested in supplying reliable energy and electricity to the largest industrial boom I think this province has ever had. So then the next question is, okay, great, we need lots of electricity. Do we actually have a wind energy resource that could meet that kind of demand? And of course, the answer again is yes. The latest assessment of onshore wind energy sites in British Columbia, which was done just this summer, and I'll talk a bit more about that in a second, looked at 121 sites and found that on those 121 identified sites, there's 48,000 gigawatt hours of electrical production, all told. Now compare that with the total current BC electricity demand of 52,000 gigawatt hours, and you can see it's pretty much equal to our total demand. And then on top of that, we have offshore wind resources, which BC Hydro estimated at almost 60,000 gigawatt hours only 3 years ago in 2009. Now in the real world, wind energy doesn't meet 100% of BC's electricity demand, because on the one hand, we've already got our big hydro resource. And on the other hand, based on what we know, it's probably not practical to go much above 30% wind penetration into the grid, but 30% is a big chunk of your electricity supply. So what we have is we have 200% of our electricity potential, and we only need to, and what I'm saying is we have an embarrassment of riches. We can choose the best resources. And just in case I've skipped something in my ad-libbing, I'll take a look at my notes. Right, that's what I wanted to say. The cost question comes next. Okay, so we've got lots of wind resources. Can we actually afford to build this wind power stuff? Is it cost competitive? What I can tell you is that in 2009, which was the last competitive call for power that we had in this province, wind energy took 47% of all the electricity contracts awarded, which is to say 47% in terms of gigawatt hours awarded. So we were already competitive for about half of energy supply. In 2010, BC Hydro, working from those numbers, assumed that if Site C went ahead, wind would take half of the remaining supply gap. They figured if Site C didn't go ahead, wind would take anywhere between 2/3 and 3/4 of the remaining supply gap, based only on lowest cost. It was an exercise where they didn't care about environment, they didn't care about social, all they cared about was the money. And wind took 2/3 to 3/4 of all future generation. Now what's interesting is that since 2009, two remarkable things have happened. The first remarkable thing that's happened, and my wind turbines are in the hall, but the first remarkable thing that's happened is that for the first time, wind turbines are now being manufactured that are built to optimize lower speed wind resources. Up until now, wind turbines have been built to maximize productivity at really, really awesome wind resources. But many wind resources are merely great or excellent and are not at the awesome stage. For the first time, the wind turbine companies are building wind turbines that are optimized to pull the maximum amount of power out of those resources. And when you look at what that does to the productivity of BC wind resources, we have an average increase in the productivity when you put these new turbines in to those kind of wind resources. The average amount of wind power that we can get increases by 27%. Okay? And these are the same turbines that are being sold at the same price, or rather they would have been sold at the same price if there hadn't been a price war. Because in the last 3 years, what's happened at the same time is that we're having increased competition between suppliers, in part because of the advent of Chinese manufacturing, in part because of the recession, but it is a long-term shift in global competitiveness. And what we have seen over the past couple of years is that wind turbine prices have dropped 20%. So you're getting a turbine that's going to give you, on average, in an average BC wind energy resource, more than 27% more electricity, and you have to pay 20% less for the turbine itself. Well, that kind of affects your economics. So I've taken the liberty of draping the results of the study. I've been talking about the study that was done for us by Garat Hassan this summer, and taking the results of that study and draping it over BC Hydro's resource option database results. This is a graph that shows the cost curve for a whole range of energy technologies in British Columbia. Wind energy has gone from that narrower salmon line to the thicker salmon line. What you can see is that the cost curve has come down, but even more profoundly, it's flattened considerably. And of course, the amount of energy has also increased. That's why the bottom line is longer or goes farther to the right than the top one. Wind energy is now indisputably the leading source of cost-competitive, clean and renewable electricity generation in BC. The only two lines that are below it, one is natural gas, and the other one, strangely enough, is coal with CCS. And they've priced that for $80. So maybe that's our real competition. But I'm more concerned with natural gas, frankly. So wind is cheaper than it's ever been. It outcompetes other renewables in British Columbia, at least, for not for everything, but for the bulk of new build in British Columbia. But now we have the natural gas question. Natural gas is really cheap. There are people who are saying that the price of natural gas it's going to remain, the price of natural gas in North America is going to remain $5 for the next 3 decades. And if you're to ask me, if I wanted electricity for the next 5 years, what would be the cheapest way to get it? I want just next 5 years. What's my cheapest way of getting electricity? I would say build yourself a natural gas plant and then shut it down after 5 years. You'll come out, or rather get someone to build a natural gas plant for you and get the power for 5 years. But nobody does that. We don't build power plants for 5 years. We're building power infrastructure for 20, 30, 40, 50 years. And the problem with natural gas is that there is a long-term price risk. And the problem with making long-term decisions about natural gas now is that prices are at their historic absurd lows. $2 for natural gas at the moment. What's happening across the pond in Asia? Why is there so much interest in sending natural gas to Asia? It's because in Asia, right now, they're paying $16 for the same amount of natural gas. Why are they paying $16 for natural gas? Because the natural price of natural gas is 1/6 to 1/7 the price of oil. And the price of oil right now, the Brent price is $110. If you do the math, you'll see it's 1/7. That the price of natural gas is 1/7 the price of oil. That's the natural price because that's where you get energy equivalence. You need 7 units of natural gas to do the same amount of work as 1 unit of oil. $2 gas in North America is not a stable price. It will revert towards the world price, and that's going to happen in several ways. The first way, and the most direct way, is to simply ship it over to Asia and get the world price. That's why we're all talking about LNG plants. Another way you can do it is fuel switching. So there's a tremendous interest in using natural gas in transportation at the moment. That's fuel switching. You're using natural gas instead of oil. You're getting the price of oil for your natural gas. And there's a really good third way too, which totally escapes me at the moment. But suffice to say, there is incredibly powerful drivers pushing the North American price of natural gas up towards at least an approximation with the world price over time. What we saw in Australia, which has a similar situation of an isolated natural gas market that has just started exporting liquefied natural gas to Asia just this year, if I'm not mistaken, is that the price of domestic natural gas immediately went up from its low $2, $3, $4 to the world price minus the price of transportation and processing of that gas to liquefy it. We can expect the same sort of thing to happen here, given the kind of volumes of natural gas we're talking about. So all of this leads me to say natural gas is cheaper now, but we're not building generation for now. We're building, it's an investment of decades. What is the cheapest thing when we look at the next 10, 20, 30 years? Wind. Wind is the cheapest thing that we can build now when we look at the lifetime of a plant. Well, that was long-winded, wasn't it? Okay. So then, another problem that you often hear about wind is that the wind doesn't blow all the time. And it's true. I admit it. It doesn't blow all the time. So you have to back it up. You have to integrate that wind. When the wind isn't blowing, you need something else to come in and supply. What is the best way of integrating a large amount of wind energy into an electricity grid? It's to have a lot of large hydro with big reservoirs. Uniquely, in large output conventional generation technologies, you can ramp up and down a dam's output very, very fast. It is the easiest and simplest way to integrate wind with conventional sort of base load technology. And with hydro, there's extremely low costs in doing that. BC Hydro did a study in 2007. They wanted to see how much wind they could integrate on the grid before there was any instance in which they would either have to curtail wind production or spill water over the dam because there was more electricity in the system than was actually demanded at that very moment. So they used data from 2007. What they found was that they could integrate 3,000 megawatts of wind at any time, at any one of the 8,760 hours of 2007, without a single instance in which someone would have had to be curtailed or water spilled over the dam. Now, since 2007, a 500 megawatt unit has gone into the Revelstoke Dam. There's two 500 megawatt units that are going into the Mica Dam. These are all pure capacity units, which means, and then we have Revelstoke Unit 6, which is planned to be installed in the current IRP by 2018. That means by 2018, we have 5,000 megawatts of integrative capacity in BC Hydro with no risk of spill or curtailment. But we can do better than that, because there's 1,000 megawatts where there is some risk of spill or curtailment, but it happens during freshet, when all the water is coming down off the mountain slopes. That happens to be the time of year when wind is least productive in BC. Wind energy producers make their least amount of money at this time. And so the risk that all 5,000, 6,000 megawatts of wind energy in this province would be producing at full capacity simultaneously at the time of least productivity is small. Would they be willing to take on the risk of being curtailed at that time in exchange for the ability to actually build a plant that can supply power the rest of the year? Yes, I think the answer is yes. So with a properly done rule, we can actually go up to 6,000 megawatts of integrative capacity in BC without actually building anything new, and without building anything that we weren't already planning on doing or already had in place. It is a remarkable advantage. This is an advantage, a competitive advantage that 5 places in the world have, as far as I can tell. BC, Manitoba, Quebec, Tasmania, Norway. Now maybe you know of some others, but those are the only ones I can think of that have that kind of freedom to integrate wind at extraordinarily low cost. It is a remarkable advantage that we have in BC. Finally, and this is the most, well, it's not finally because I got to talk about all the other advantages, but yet another cool thing about wind is that it actually strengthens BC's power supply, right? A lot of talk about renewables is couched in, well, what do we have to give up to have this nice green stuff? We actually get a better electrical system when we integrate wind onto the grid, and I'll tell you why. It's because right now our power system is anti-correlated, or our supply is anti-correlated to our demand. We have to run our hydro system most during freshet. It's when all the water is coming off the mountains. We have to run this stuff through the dam. We're very, very close to exceeding what we actually need. We have to run the water through the dams at this point in time. But when you look at the profile of wind energy, that's the yellow line on the bottom, and compare it to BC's electricity demand by month, you'll see that they're almost exactly parallel. Wind energy is most productive in the winter months, and that's when we require the most electricity in British Columbia. If you were to integrate 6 gigawatts of wind, that's our integration limit, into our existing hydro system, what you get is that dotted green line. You have a power output pattern that is far more closely linked with our actual demand in this province than what we have now. So again, if you integrate wind in BC, you end up with a system that is better suited to British Columbia's power needs than the already awesome system we have now. That's pretty remarkable. And then there's jobs and investment. So 5,200 megawatts of wind would create 22,500 job years of construction. There would be another 7,500 person years of employment through operations and maintenance. And those jobs are steady, long-term jobs that are actually going to be in small communities, rural communities, First Nations communities, just because of where our wind resources in this province are. There will be $16 billion of investment, $3.7 billion of direct benefits to British Columbians. And the people who came up with that estimate of the benefits assumed that there was no skilled labor for the detailed wind energy specific stuff in constructing turbines, and they assumed that there wasn't a single manufacturing job in the wind energy sector in this province. If the province committed to saying, yes, we recognize the advantages of wind power, we recognize the importance of electrifying new demand and meeting that demand using clean and renewable electricity, if you provided those long-term signals to industry so that they could see this and they can see, okay, there's going to be a big build here, it makes sense to locate skilled personnel here, our skilled construction workers, or to train them up. It makes sense to put some manufacturing or assembly in British Columbia. Those job totals can go up dramatically. Now, I'm not calling for incentives or subsidies for this. I'm just saying if you give the industry clear signals that there is a big market in this province, then we can expect further economic development to come of that. Oh yeah, and there's environmental benefits. Okay, only 1 to 5% of the area that you require for a wind farm, because wind farms are aerially extensive. There's a lot of distance between the wind turbines, but only 1 to 5% of that area is actually converted for the requirements of the wind farm. The access road, the pads at the base of the turbines, the distribution line that takes the electricity back to the grid. The rest of that land can be used for what it was used for before. So in agricultural areas, that can be used, continue to be used for agriculture. In a timber license area, that can continue to be used for that purpose. And it remains habitat. There are no toxic and residual wastes from wind power. We neither use nor divert water in wind power. There are no emissions from energy production itself, and over the life cycle of the turbine, there's a very good energy return. It takes 9 to 18 months, depending on the kind of regime you stick your turbine in, to generate as much electricity as was required to manufacture, install, and decommission that turbine. And all the rest is gravy, and a wind turbine is built to last 20 to 25 years. And now, finally, we come to climate leadership. Shauna tells me I have 1 minute. So my punchline is you get all of this, all of these benefits, and if you were to implement the BC Wind Vision, we asked the folks at the Pembina Institute to say, what is the emission reduction benefit that we get from installing 5,250 megawatts of wind energy to meet largely this new industrial demand instead of natural gas and diesel? They crunched the numbers and they came back and they said, you would reduce your emissions by 8.86 million tons a year in the year 2025 and every year after that, if you were to do that. Now, to be sure, if you're having that kind of industrial development, your emissions are going to go up. So this is a reduction from that business as usual case. But that's almost 9 million tons in a province where we currently emit 63 million tons. This is a huge emission reduction opportunity. In fact, it's the biggest one I can think of. And that's the punchline for, I think, many of you in the audience here. It certainly is a good punchline for me. So what do we know about the wind power advantage for BC? So it integrates with and actually improves BC's grid. We get 9 megatons of greenhouse gas reductions per year. It's a low economic cost. It is the cost leader when it comes to new generation. We get jobs and investments out of it. There are low environmental impacts out of it. And we have the power to grow BC's economy. I'm going to say one more thing. I'm going to eat into my time. And that is when we talk to government, I talk about all these great things, and then we say, and the people of British Columbia are tremendously in favor of wind energy. We have polling results where 75% say, yes, we want more wind energy in this province. The politicians come back to us and they say, yeah, we know they say they want that, but do they really? We think they're interested in low cost. The Friends of Wind is a group that wants to stand up so that when the politicians say, but does anyone really care? This is a group that says, actually, yes, we really do care. If you would like to be a friend of Wind, I would certainly encourage you to sign up. There's a sign up in the hall. We've got postcards and business cards as well, or you can ask me about it. And now, Shauna, now I'm done. Thank you.
Thank you. Wayne, is this working? Great, perfect. So the first question, in just a minute, I'm going to ask you to come up with your questions. We like to give hard questions to our presenters, so think about a few hard questions. But we have one from the Twitter world already. And the first one is, how does CanWea work with the energy storage industry for remote areas without local hydro dams?
Wow, okay. That's a good question. Wind energy has applications in off-grid applications, and it's the challenge can be storage. So typically, what happens in those sorts of situations is you're going to have a diesel hybrid system where you're getting some of your power. It can be up to 30–40% from wind energy, and then that is backed up with diesel. Now, in most of these communities, the community was already running on diesel. So the trick is to have a proper control system that will allow you to switch back and forth between diesel and wind. And I know that there's a number of Alaskan communities that have had some success, well, actually, they've had demonstrated success in doing that. And there's a lot of work going on that. I have to say, however, that's not a big focus of CanWea's activities. So there is work going on there. It's promising, and there's certainly application to isolated and coastal communities in British Columbia as well. And so there is stuff going on. It is a potential thing, and I'd be happy to direct folks to resources on that if they're interested.
Okay, John, I see you standing there. You need to have a seat if you'd like, but go ahead. You're all right. I'm going to give you, because I know how you're going to be pithy, short, brief.
Flattery gets Shauna a long way. I'm John Richards, and I teach in the public policy group. You're making a good case, and you're defending yourself against the low-cost producer with natural gas right now. The levelized unit cost per kilowatt hour, I still think in terms of kilowatt hours was a megawatt hour, but you can translate, is about 8 to 9 cents for their Site C.
94.
Was it?
It's 94 now.
Okay, well, that's 9.4 cents. Okay.
Yes.
What, if I asked you to do an analog, what's your range for your thermal? For your wind, assuming that we'll ignore for the moment any of the issues about storage. What would your guys need as a price in order that they can cover their levelized cost?
The Garad Hassan study, which was done this summer, came up with a lifetime cost of energy, which was made as comparable to the unit energy cost as possible.
Yeah.
There is one difference in that it simply wasn't feasible for us to estimate the cost of building substations and interconnection. Okay. So those numbers aren't factored in, but the lowest cost wind energy resource in the province, according to this study, starts at 80. And if you look at the resources that climb up from there, I believe that there is more gigawatt hours coming in at a lower price point than the $94 for Site C. So it's more than 5,500 gigawatt hours of wind supply. Now, mind you, that doesn't include the cost of interconnection, And in fact, the cost of Site C does not include the cost of improvements to the transmission grid. So,
Can I summarize accurately by saying $94 is what you're going to use as the estimate for Site C, and that you think that about 50% of your potential capacity could come in at under 94?
I'm saying that we have as much production that can come in for that price according to the Garad-Hassan report that was just done.
Okay, thank you.
Great. Other questions? Great. I have 1, 2, and then I have another one from the Twitter world. So we're going to go here, and then we'll go.
Great. I've heard some arguments against the way that wind turbines are produced, and that some of the rare earths that are needed to make a magnet in the middle of the wind turbine. I believe it's called diaminium or...
Neodymium.
Thank you, yes. So a lot of that comes from China, where the working conditions are not necessarily the greatest, and citizens around some of these mines have talked about the toxic residues from that mining. Mm-hmm. So how do we get around the social issues around the production of wind turbines?
Neodymium is a very useful thing. Neodymium is a super strong magnetic material. And what it enables you to do is make a more powerful magnet and hence a more powerful motor in a smaller area than you can using other materials. That's important if your motor is 250 feet in the air. Right? It's just less stuff to hold up. You just get more bang for the buck. So neodymium is important, and with permanent magnet motors, you use neodymium. It's not the only technology you can use. For the longest time, we were using induced magnets, which don't use neodymium. So it's not like it's the only thing we can use. The other thing that's worth noting is that China doesn't have a monopoly on the world's neodymium. It currently has a near monopoly on the production of neodymium. But what we've got right now is people all over the world looking at other neodymium deposits and bringing that to market. So I suspect that situation of having overwhelmingly a single country supplying neodymium is going to resolve itself within the medium term.
What's the toxic properties of that?
I have another question. I think the social issues that you raised is an important one that I'm not sure has been completely addressed yet.
Hi, my name is David Hendrickson from Real Estate Foundation. I actually have 3 questions for you, but they're really quick. Mm-hmm. Call me naive, but why aren't we doing this now? What's the number one policy barrier? Number 2, can you talk about birds? And number 3, can you talk about sounds?
Sure.
High-pitched ones.
Sure. The number one policy barrier is that there is no call for power, that the current load forecast of BC Hydro shows that there is no need to go for a call for power. So we really can't do much unless someone actually says, yeah, we would like to buy some electricity. You asked about birds. Okay, let's talk about birds.
And that actually, thank you for that, David, because that was the question coming from the Twitter world. Have there been any studies on the effects that these wind farms have on bird populations?
So let's be clear. Wind turbines can and do impact birds. Okay. The reason that wind turbines go through such a regulatory process is because, in part, because of bird impacts. So before a wind project even gets off the ground, there has to be 1 or 2 years of bird and fauna and wildlife studies to see what kind of birds are in the area. The siting is affected by that. A lot of projects don't go ahead because of bird habitat. And as a result, the factor back in 2002 for bird impacts was 3.04 birds per megawatt per year, bird impacts, okay?
What's that, bird impact?
Dead birds, okay? The reason that we know that it's 3.0.4 is because no industry is required to go around their facility for 2, 3, or 5 years after it's built with sniffer dogs looking for dead birds and then multiplying that by a factor of 4 or 5 for every one they catch, for the ones that were carried off by foxes or whatever, or that were just missed by the sniffer dogs, okay? So, you know, so we've got a lot of certainty about that number because we spent so very much time at every single wind farm collecting that data. This is a graph that was done back in 2002 showing the relative source of bird impacts. Okay? And this is where wind turbines are on the chart. But I would argue that they're not the biggest problem. Okay? The numbers are a lot more loosely constrained for everything else because no one's looking. Right? That's why the rounding error is 13 million per year, and the number of birds that I've got here is about 140, 150,000. The other thing to keep in mind is I increased that number by 10 times. Okay, because this work was done in the year 2002. Since 2002, there's 10 times more megawatts in the United States. So I just increased their number by 10 times, and that's what's on this graph. Keep in mind that wind energy is now about 3%, give or take, of the US's total energy supply. We can only have another 10-fold increase in the United States before you really can't have any more wind energy in that country. So at worst, I would suggest what we might get is a 10-fold increase, and that would take us up to, somewhat over 1 million. Okay, and I would say on a comparable basis, there's a lot of other factors that are impacting birds. So that would be.
And the third is sound.
The third is sound.
And if there are other questions that are coming up, Nick, just let me know.
Oh, there we go. So here's the sound from wind turbines. So now we've got wind turbine in the middle of the 50 decibels. That's at the base of the turbine. Okay, across North America, the general rule is you cannot have a residential property where you're getting more than 40 decibels inside the home, or on an undeveloped property, you can't have more than 40 decibels at the nearest property line to the wind farm. Now, I have a little sound meter thing here, and if you just give me just a moment, I'll open it up.
Is that CanRIA's data?
Sorry?
Is that CanRIA's research, or where's the source for?
I don't know what the source of that scale is, but it's thanks. So decibels are a log scale. So 50 is 10 times more than 40, 60 is 10 times more than 50. Right now, we're in the mid-60s. So everyone be quiet. I see the fans going. 62. 62 decibels right now, just to give you a sense. And it's a log scale. Everyone yell. Okay, we got high 70s. Okay? So 40 decibels is pretty much the North American standard for the closest a residential property can get to a wind farm. And that's cumulative. It's not just the wind farm, it's all of the sound coming in at the receptor.
Other questions?
You mentioned that you don't think you need to have a fixed-term contract, like a feed-in tariff similar to Ontario. You think you can encourage private investment in the magnitude necessary, given uncertainty in price?
We don't have a feed-in tariff in BC. We don't need one.
You don't think you need one?
No, what we need is an open, transparent call for power where the least cost supplier can build the project.
Other questions? The reason we're using the mic, just so that others that are listening in on the webcast can hear your questions.
Thank you. I was just wondering if you could comment on DC versus AC grids. Is there any change that way, or does that affect your power?
Oh boy, yeah, sorry. I wish I could answer that one, but that one's over my head. Perhaps I can put you in touch with someone who could give you an intelligent answer? Okay.
Hi, so it looks very interesting, especially for the standard installations you talked about. You did mention the cost of distribution. Is there any new technology being developed for very local, like building top systems? And kind of related to that, there's been some, I think, scientific study looking at the feasibility of very high altitude wind turbines and whether that could meet like base demand continuously.
Right. Okay, a bunch of interesting points there. There are certainly a whole range of small turbines. We talked about it in the context of off-grid and isolated communities. Interestingly, Canada is actually is a home to a large number of small wind turbine manufacturers. It's the one segment of the wind turbine industry that we actually have quite a strong position in. So, yay, small wind. What I would say is that there's a reason that wind turbines are just so darn large, and that is because there's very, very significant economies of scale. The higher you get off the ground, the stronger the wind blows. The longer your blades are, the length of the blade the amount of wind energy you access is the square of the diameter of the blades. So it pays to be bigger. There's big efficiencies of scale. You want to go up high because the amount of energy you get out of the air cubes as with increases in the wind speed. So a 10% increase in wind energy in wind speed will give you 40% more energy. So there's real drivers to go high and to go big. Small wind turbines or turbines on buildings, they don't choose the resource. It's where the building is. They can't get very high and the blades can't be very big. All of that means that it's going to be less, it's going to come in at a higher cost than a utility scale wind farm. That said, it can be done. There's lots of suppliers and we should go for it if that's what works for you in your situation. When it comes to the new technology like the high altitude stuff, this stuff is great. It's barely off the lab bench. So what I'm talking about here when I talk about utility scale wind turbines is a mature technology that's 7 or 8 generations in, has come down the cost curve, is fully cost competitive. What you're talking about there is something like wave or tidal, very promising, the energy is there, it can be captured, it's going to take a long time before we come down the cost curve. Should we invest in that? Should we make sure that these new technologies do come down the cost curve? Of course. Yes, that's a great idea. And 15, 20, 30 years from now, they'll be ready and we can use them and turn them to good account. So, but we can't expect it tomorrow.
I have a quick question. Given the job strategy of the provincial government and their affinity, it seems to be, to liquid natural gas, why aren't you front and center of that debate? What is stopping?
But I am front and center.
You might be here, but we're not hearing it in the public arena.
Well, I guess I have to go and work harder. I think there's an excellent case to be made. I am communicating with the provincial government, with members of the government and the opposition. I presented to the budget committee just yesterday, bringing up many of these things. So I'm doing my best, but well, this brings it back to the Friends of Wind. As I said, I go over and I talk to government, I say, yay, wind is awesome, right? Look at all these awesome reasons for thinking wind is awesome. And they say, yeah, that's great, but we don't think people really want it. We think what people want is low cost electricity, and that's what natural gas will give them. And then I say, well, look at these polling results. They're incredibly consistent. They say large majorities of people want low-impact renewables. Large majorities want wind energy specifically. And they say, well, we don't believe the polls. Because anyone can say, yeah, I like wind energy on a poll. So what we actually need is we need citizens, we need voters to say, actually, I do care about wind. And when these issues come up, if the industry flack speaks in favor of wind energy, well, it's not unexpected. But if citizens start speaking up for wind energy, I think that makes a bigger impression, and perhaps that's what we need to do more. And in fact, that's why I'm talking to folks like you today. It's part of that effort.
I think we have one more question from the Twitter world, and then we are going to close off. So the last question from Scott. Please speak to the manufacturing capacity and expertise that currently exists in Canada and where and how it can grow.
Gosh, well, I've already touched on this a bit when it comes to the small wind. So we have a number of small wind manufacturers who are designing and manufacturing wind turbines. And in fact, we have a manufacturer in Surrey, Endurance Wind, which sells its products all over the world, highly regarded. And they are, they're literally within the metropolitan region. In the past, a feed-in tariff, when it has been used, is in part a way of getting electricity supply into whatever jurisdiction has put the feed-in tariff in place. But mostly it's an industrial development strategy, and it's always been an industrial development strategy. By putting a feed-in tariff in place, you're creating a rock-solid market that gives manufacturers the confidence to base production facilities in that jurisdiction because they have an internal market that they can sell to. This is a trick that has been used in Germany, in Spain, in a whole manner of European countries, in the United States. No, excuse me, pardon me, not in the United States. In Ontario, and and it works as an industrial development strategy. But we now live in a world that has a lot of wind turbine manufacturing capacity. And with each new person who tries a feed-in tariff, your total has to be bigger, your incentive has to be bigger in order to get this industry, which is now quite mature, to locate in. So it seems to be paying some dividends in Ontario. Manufacturers of solar and wind are indeed locating in Ontario. Am I recommending that for British Columbia? Not so much. I think what we do is we compete on price. I think if we have a large market, we're going to see some manufacturing, some assembly come over because that will be the least cost place to do it. I think that this is now such a mature industry, and what we're competing with in BC is on price. And so that would be my response on that one.
I want to say thank you. We're going to close off, but I know that Nicholas can spend a few more minutes in a one-on-one. So, but I want to say thank you. This was really informative. Now, normally we'd push you a little bit more and raise more provocative questions. But I think, so in the sense, I think you've had a pretty nice ride through it. But I think part of that is because you're presenting such a compelling case. So I want to thank you for that and bringing so much information to the table. You've also brought a lot of information here and outside for others to look at. So I'd encourage everyone to do that. There has been a piece of paper too circulating. That's how we invite you to Carbon Talks. So if you want to make sure that you get an invitation to upcoming Carbon Talks, please let us know your name and email address. I want to say a personal thank you to those that have joined us through the webcast. A thank you to Chris for following up, and Justin, to my colleague Maria, and to Claire for their assistance in organizing this. And a very, very big thank you to you, Nicholas.
Thank you very much.
Tom is our newest addition, and Tom was absolutely pivotal to this. So I apologize, Tom. I missed you on that. Tom Malcolm. We will be doing next month, we're going to be looking at liquid natural gas. We'll let you know the details on that. So stay tuned for November. So thanks again, everyone.